They called it the Screamin' Jimmy, and for good reason. When a Detroit diesel two-stroke hit full throttle, the mechanical whine could be heard for miles. In the late 30s, General Motors made a bet that would change American transportation forever: build lightweight diesel engines that could outperform gasoline while weighing half as much as existing diesels. What they created powered everything from Greyhound buses to military landing crafts, but the company that dominated trucking for decades would eventually face an impossible choice: abandon the technology that made them famous, or watch competitors steal their business. In 1938, General Motors established the GM Diesel Division, setting out to revolutionize American transportation with lightweight, high-speed diesel engines. Charles Kettering, GM's influential head of research and developer of the electric starter, had championed diesel advancements since the early 1930s. Kettering believed that lightweight, high-speed diesel engines could revolutionize commercial transportation, but the existing technology wasn't suitable for mobile applications. The marine and stationary diesels of the era were massive, slow-running engines that weighed thousands of pounds and operated at just a few hundred RPM. Kettering envisioned diesel engines that could run at 1800 RPM or higher while weighing less than comparable gasoline engines. This required fundamental innovations that no existing manufacturer was pursuing. General Motors established the Detroit Diesel Engine Division on January 1, 1938, with headquarters in Detroit and manufacturing facilities planned for the city's industrial corridor. The division's first assignment was to develop a family of lightweight diesel engines specifically for trucks, buses, and industrial equipment, markets that had been largely ignored by existing diesel manufacturers. The breakthrough came with the Series 71 engines, featuring exactly 71 cubic inches of displacement per cylinder. The first engine off the production line was a 671, producing around 170 horsepower from 426 cubic inches of total displacement. But the real innovation wasn't the displacement. It was the two-stroke design that fired on every revolution instead of every other revolution. The key to making two-stroke diesels work was the Roots-type blower system, which GM designed and built in-house. While based on the Roots principle, the design was in the public domain by that point, so no license was needed. The blower didn't just provide boost, it was essential for scavenging exhaust gases and supplying fresh air for combustion. The Roots blower created the distinctive screaming sound that would become Detroit Diesel's signature. Operating at 1.5 times crankshaft speed, the blower produced a mechanical whine that combined with the rapid firing of the two-stroke cycle to create an unmistakable exhaust note. This sound would become so associated with Detroit Diesel that operators could identify the engines from blocks away. Greyhound lines became Detroit Diesel's first major customer in 1939, ordering 671 engines for their new PD 3751 intercity buses. Greyhound's testing showed that the 671 delivered 6.2 miles per gallon compared to 4.8 miles per gallon for comparable gasoline engines, a 29% improvement that justified the higher initial cost. The engine's 165 horsepower output was perfectly matched to Greyhound's performance requirements. The U.S. Army began evaluating Detroit diesel engines in 1940, initially installing 671 units in experimental trucks and generators. Army testing at Aberdeen Proving Ground showed that the engines could operate reliably in temperatures from -40 to 125 degrees Fahrenheit, a range that exceeded the capabilities of most gasoline engines. The mechanical fuel injection system eliminated the carburetor icing problems that plagued gasoline engines in cold weather. World War II transformed Detroit Diesel from a startup into a major industrial force. The company's production capacity expanded from 1,000 engines per year in 1939 to over 57,000 engines in 1943 alone. New manufacturing facilities were constructed in Detroit, with assembly lines specifically designed for high-volume production of military engines. The M4A2 Sherman was powered by the GM 6046 twin diesel, which combined two 671 inline sixes through a common gearbox. The diesel setup reduced fire risk and improved range. Because of this, M4A2s were supplied in large numbers to the Soviet Union and British Commonwealth through Lend-Lease. The U.S. Marine Corps used them in the Pacific. Over 8,000 M4A2 tanks were built with 671 engines between 1942 and 1945. Landing craft used 671 engines because their compact size allowed more cargo space while providing the 165 horsepower needed to beach heavy vehicles. The LCVP, Landing Craft Vehicle Personnel, used a single 671, while the larger LCM, Landing Craft Mechanized, used twin 671 engines producing 330 horsepower total. These engines powered the D-Day landings and countless other amphibious operations throughout the Pacific and European theaters. The unit injector system developed during this period became legendary for its field serviceability. Each injector contained 47 precision-machined parts assembled into a single unit that could be removed and replaced in less than 30 minutes. The injectors operated at 1500 psi injection pressure, precisely timed to deliver fuel at the optimal moment in the combustion cycle. When an injector failed, mechanics could swap in a replacement without specialized tools or extensive downtime. The post-war boom created enormous opportunities as America's economy shifted into high gear. The Federal Aid Highway Act of 1956 authorized the creation of the Interstate Highway System, creating an immense new demand for long-haul trucking that could take advantage of diesel fuel economy. Urban transit systems were expanding rapidly, with cities like New York and Chicago ordering hundreds of new buses annually. While the U.S. Army was Detroit Diesel's largest customer during and after the war, Mack Trucks also became a significant partner in the late 1940s, installing 6 to 71 engines in their L-Series trucks. The Mack L761 with a 671 engine could haul 80,000 pounds gross vehicle weight while achieving 5.5 miles per gallon, performance that made it popular with long-haul operators. By 1950, over 60% of Mack's heavy-duty trucks were equipped with Detroit diesel engines. White Motor Company began offering 671 engines in their WC Series trucks in 1948, marketing them specifically to owner-operators who needed maximum fuel economy. The white WC-22 with a 671 engine became known as the million-mile truck, because many examples accumulated over 1 million miles before requiring major overhauls. The engine used replaceable dry cylinder liners, which meant the block itself could be rebuilt and reused, but replacing them typically required pulling the engine from the chassis. Recognizing the success of the Series 71, Detroit Diesel introduced the Series 53 in 1957 with 53 cubic inches per cylinder. The 453 produced 130 horsepower from 212 cubic inches, while the 653 generated 195 horsepower from 318 cubic inches. These engines were specifically designed for medium-duty applications where the full power of a Series 71 wasn't needed, but diesel fuel economy was still desired. International Harvester became the largest customer for Series 53 engines, installing them in their Lodestar medium-duty trucks beginning in 1958. The IH Lodestar, with a 453 engine, could achieve 8.2 miles per gallon in delivery service, compared to 5.8 miles per gallon for comparable gasoline engines. This fuel economy advantage made the Lodestar popular with bakeries, beverage distributors, and other businesses that operated large fleets of delivery vehicles. The Series 110 was introduced in 1957 for applications requiring maximum power density. With 110 cubic inches per cylinder, the 8V110 produced 335 horsepower from 880 cubic inches, the most powerful engine Detroit Diesel had ever built. These engines were used primarily in marine applications, stationary power generation, and severe-duty off-highway equipment, where their massive size and power density were essential. The distinctive sound of Detroit diesel engines became part of American culture during the 1960s. The Peterbilt 351 with a 6V71 engine became an icon of American trucking, featured in movies like Smokey and the Bandit and Convoy. The engine's exhaust note was so distinctive that truckers could identify specific engine models just by listening to them on the CB radio. Construction equipment manufacturers embraced Detroit diesel power during this period. Caterpillar offered 671 engines as options in their 631 and 633 scrapers, while Euclid used 8 V71 engines in their R-Series off-highway trucks. The engine's tolerance for dust, heat, and heavy loads made them ideal for construction applications where reliability was more important than fuel economy. Marine applications expanded significantly during the 1960s as commercial fishing fleets discovered the advantages of Detroit diesel power. The 671 became the standard engine for West Coast salmon boats, while Gulf Coast shrimp boats preferred the 8V71 for its additional power. The engine's mechanical simplicity meant they could be serviced by boat crews using basic tools, crucial for vessels operating far from shore. However, competition from Cummins and Caterpillar began to intensify during the late 1960s. Cummins introduced the NH230 in 1967, a four-stroke engine that produced 230 horsepower while achieving better fuel economy than comparable Detroit diesel engines. Caterpillar's 3306 engine, introduced in 1968, offered similar advantages in fuel efficiency and noise levels. The 1973 oil crisis created immediate challenges for Detroit diesel as diesel fuel prices increased from 36 cents per gallon to over 55 cents per gallon virtually overnight. Fleet operators who had been willing to accept the fuel consumption characteristics of two-stroke engines suddenly became very concerned about operating costs. The scavenging process that made Detroit diesel engines powerful also meant they consumed 10 to 15% more fuel than four-stroke alternatives. Detroit diesel's response was the Series 92, introduced in 1974 with improved fuel economy and reduced emissions. The 8V92 produced 318 horsepower from 736 cubic inches while incorporating a more efficient turbocharging system and improved combustion chambers. The engines were marketed as fuel squeezers, promising 8 to 12% better fuel economy than earlier Detroit diesel engines. Freightliner was among the first major truck builders to offer 8V92 engines in their cabover models in the mid-1970s. The Freightliner FLT with an 8V92 could achieve 5.8 miles per gallon in long-haul service, compared to 5.2 miles per gallon for the 8V71 it replaced. This improvement helped maintain Detroit diesel's competitiveness as fuel costs continued to rise. The 12V92 became popular in marine applications, producing 485 horsepower from 1,104 cubic inches. Sport fishing boats in the 45 to 50-foot class commonly ran twin Detroit diesel 8V71s or later 8V92 turbo aftercooled packages for high-speed offshore fishing, where the engine's power density and reliability were more important than fuel economy. The engines could operate continuously at 2,100 revolutions per minute, producing maximum power for hours at a time. Environmental regulations began impacting Detroit diesel engines in the late 1970s as the EPA implemented increasingly strict emission standards. The California Air Resources Board was particularly aggressive, requiring significant reductions in particulate matter and nitrogen oxides that were difficult to achieve with two-stroke technology. The visible smoke that was characteristic of Detroit diesel engines became unacceptable in urban areas. The challenges of the 1980s forced Detroit diesel to fundamentally reconsider their technology. The Clean Air Act amendments of 1990 established emission standards that would be impossible to meet with two-stroke engines, while fuel efficiency had become the primary concern for fleet operators. Customer surveys showed that noise levels were also becoming important as trucks operated increasingly in urban environments. Development of the Series 60 began in the early 80s as a clean sheet design incorporating four-stroke technology and electronic controls. The engine displaced 12.7 liters and was designed to produce 350 to 500 horsepower while meeting all anticipated emission standards through the year 2000. The development program cost over $500 million and involved 200 engineers working for 4 years. The Series 60 was launched in 1987 with the Detroit Diesel Electronic Control D-Deck system, the first fully electronic engine management system used in commercial vehicles. D-Deck controlled fuel injection timing, turbocharger boost pressure, and engine protection systems, while providing comprehensive diagnostics that could identify problems before they caused failures. The system used a 16-bit microprocessor running at 8 MHz, advanced technology for its time. Fuel economy improvements were dramatic, with fleet testing showing 15 to 20% better fuel economy compared to the 8 V92 engines the Series 60 replaced. Consolidated Freightways reported achieving 6.8 miles per gallon with Series 60 powered trucks compared to 5.7 miles per gallon with their 8 V92 fleet. This improvement translated to annual fuel savings of over $3,000 per truck for high-mileage operators. The Series 60 achieved 50% market share in Class 8 trucks by 1995, making it the most popular heavy-duty engine in North America. Freightliner, Peterbilt, Kenworth, and International all offered the Series 60 as standard equipment, while Mack and Volvo offered it as an option. The engine's combination of power, fuel economy, and reliability made it the preferred choice for long-haul operators. Corporate changes began in 1988 when General Motors formed Detroit Diesel Corporation as a joint venture with Penske Corporation. Roger Penske brought transportation industry expertise and entrepreneurial management to the partnership, while GM provided manufacturing facilities and engineering resources. The joint venture allowed Detroit Diesel to operate independently while maintaining access to GM's resources. Under Penske's leadership, Detroit Diesel expanded internationally, establishing manufacturing partnerships in Brazil, Mexico, and other markets. The company also diversified into remanufacturing, offering rebuilt engines and components that extended the life of existing equipment while generating recurring revenue. By 1993, Detroit Diesel held 33% of the North American heavy-duty engine market. Daimler Chrysler acquired Detroit Diesel Corporation in 2000 by tendering $23 per share for the 78.7% it did not already own, a transaction valued at about $423 million, and completed the merger in October 2000. The acquisition brought Detroit Diesel under the same corporate umbrella as Freightliner, Western Star, and Mercedes-Benz trucks, creating opportunities for integrated product development and global market expansion. Integration into Daimler trucks provided access to advanced European diesel technology, including common rail fuel injection systems and sophisticated after-treatment technologies. The Mercedes-Benz OM460 engine technology was adapted for North American applications, while Detroit Diesel's expertise in electronic controls was applied to Daimler's global engine programs. The rebranding as Detroit in 2010 reflected the company's evolution from an engine manufacturer to a complete powertrain supplier. The new brand encompassed the DT12 automated manual transmission, developed in partnership with Mercedes-Benz, and Detroit axles designed specifically for fuel efficiency. The integrated powertrain approach allowed optimization of the entire drivetrain rather than individual components. Modern Detroit engines like the DD13, DD15, and DD16 incorporate advanced technologies that would have been impossible with earlier designs. The DD15 uses a common rail fuel injection system operating at 2,500 bar pressure, while the aftertreatment system includes a diesel oxidation catalyst, diesel particulate filter, and selective catalytic reduction system that reduces NOx emissions by 95%. The DD13 can achieve up to 8.5 miles per gallon in long-haul applications, dramatically more efficient than the two-stroke engines of previous generations. Advanced combustion systems, precise electronic controls, and optimized turbocharging have transformed diesel engines from fuel-hungry power plants into efficient, clean-running systems that meet the strictest environmental standards. Global expansion has taken Detroit engines to over 60 countries, where they power trucks, buses, and industrial equipment, in applications ranging from urban delivery to long-haul freight. The Freightliner Cascadia with a DD15 engine has become popular in Australia and South Africa, where its fuel efficiency and reliability are valued by operators covering vast distances. The legacy of Detroit Diesel's two-stroke engines lives on in thousands of vintage trucks, boats, and industrial machines where enthusiasts maintain these mechanical marvels as symbols of American industrial heritage. The sound of a 6V71 at full throttle still draws crowds at truck shows and antique equipment demonstrations, reminding people of an era when engines were purely mechanical devices that could be understood and repaired with basic tools and determination.